Hello and welcome to part 2 of our week 2 lecture. So for this video and for this section, we're going to cover just what is multiple linear regression. So it's a statistical technique that uses several explanatory variables to predict the outcome of a response variable. To try to frame it kind of in where it fits. So first of all, I know I told you last week in week 1 that you've got correlation, linear regression, then multiple regression, right? They all kind of flow together, one piggybacks kind of after the other. So in this case, how do you get to correlation? And then we'll get to that linear regression and multiple regression. So your data type has got to be continuous, which means it's numeric. Right? So it's continuous numeric data. Our parametric assumptions met. For most of what we do, we'll just assume this, and we'll look into this a little bit more with multiple regression. But in general, we just assume yes, and that leads us to a Pearson's correlation. And so remember, this is testing relationship between two or more variables. In this case, it really is just two variables. So for correlation, it's just two variables. We then expand on this with predicting, and that's another big difference, is this is relationship, and that's important because correlation is always looking at the relationship. So for example, if you were getting a quiz question where you were looking at the relationship, or if you write a hypothesis looking at a relationship and it's got two numeric continuous variables, it's going to be a correlation. But if you want to try to predict, so if you've got, and you still have to have two continuous, so that would be two numeric variables. So if you have at least two numeric variables and you want to predict the outcome, this is going to be a simple regression. So simple regression, right, if you just have two numeric / continuous variables. If you have more than two, so if you have more than two predictor variables, so more than two variables that you think are going to help predict, right, that response variable, then you're going to be doing a multiple regression. So rule of thumb, if you've got two numeric variables and you're doing a relationship, it's going to be a correlation. If you've got two numeric variables and you want to predict something, that's going to be a simple regression. If you've got more than two numeric variables, then it's going to be a multiple regression. So that's kind of how they fit together, and that you're using a lot of the same data. It's just kind of how you want to piece it together, or maybe you don't have three variables. So if you don't have three variables, you're not doing a multiple regression. But if you have three or more variables, then you definitely would be doing a multiple regression, at least as long as you're predicting and they're all numeric. So a little bit more just to help kind of key in the difference between correlation and regression, because this is an important difference. And when you go to do your dissertations or just as you're reading the research literature, anything like that, I want to make sure that you understand that a correlation is all about relationships. Regression is about prediction. For a correlation, the variables move together. So you remember how we said we could have a positive or a negative relationship. So positive relationship means that either both variables go up or both variables go down, right? But they move together, or they can, that's positive, right? They either both go up or they both go down. Negative would be one goes up, the other goes down. Or if one goes down, the other goes up, but they move together. That's that relationship. For a regression, because we're dealing with prediction, the variables indicate cause and effect, which is a really important thing, because correlations, you can't determine cause and effect. You can just say they happen to move in the same direction or they happen to move in the opposite direction. Where regression allows for prediction and indicating that cause and effect, that this variable can predict, right, X amount, and we can actually get that percentage of this variable. So honestly, I love regression because I love, and you're going to see, I get really excited. I love that prediction aspect. I love the idea of knowing that this variable predicts X amount of this variable, right? Or this is how these variables kind of play in to help understand that response variable. So I think regressions are really cool. So once again, though, in correlation, X and Y are interchangeable. So when you go to put it into JASP, it doesn't matter which one is first, which one's second, right? They're the same thing. They're interchangeable. In a regression, X and Y are not interchangeable. Absolutely not. You've got a predictor variable or multiple predictor variables and one response variable. And they do matter, and which one is which determines which box you put it in, right? So you've got your response variable, which you only have one response variable. Doesn't matter if it's a multiple regression or a linear regression, you only have one response variable. That's the variable you're trying to measure, right? The other ultimate outcome there. And then you've got predictor variables. On a linear regression, you have one predictor variable. In a multiple regression, you have more than one predictor variable. And then last, for a correlation, you've got spurious nonsense correlations, which means you can have, chocolate relates to how old people live. Well, that's a nonsense correlation, likely, right? Because I don't really think, I'd love to hope that all the chocolate I love to eat will help lengthen how long I live, but I really don't think it does. I'm guessing a lot of other factors play into that. Or you even have nonsense correlations. If you actually Google spurious correlations, you'll get lots of different examples, like cheese consumption. So the higher the cheese consumption in the in a state, the higher the number of people who die getting tangled in their bed sheets. And that is a legit correlation. It's a legit positive, significant correlation. But do eating cheese and getting tangled in your bed sheets have anything to do with each other? Probably not. I'm guessing it's a hard no. That's a spurious correlation. So even though two things can be related, it doesn't mean they have anything to do with each other. It doesn't mean they can, no cause and effect. Where with a regression, you've got no such thing as a nonsense regression, because you're determining prediction, because you're saying specifically, this predictor accounts for X amount towards this response variable, right? There is no nonsense, because if there was no relationship, it would just show up as 0. It would just show up as there is no relationship. So you can't have a spurious, no nonsense correlation in this case. All right, and then our last slide for this part of the video series here, just to make it clear, a linear regression, right? So first of all, both linear and multiple regression deal in prediction. So their hypotheses have to do with prediction. The difference between the linear and multiple linear regression, so very similar. The difference, though, is that a linear regression, you only have a single predictor, right? So only one X variable leading to that Y, which is your response variable. So in this case, Y, for both the linear regression and the multiple regression, are your response variable. That's your dependent variable, is that Y variable. That's the thing you're ultimately trying to measure, right? So this predictor variable, this 1x for the linear regression, is your independent variable. For a multiple linear regression, you need more than one. So you need at least 2. Now you can have kind of unlimited numbers of predictors, but you need at least more than one, because if you only have one, it's a linear regression. So to have a multiple regression, you have to have more than one predictor variable. But still, regardless of whether you do a linear regression or a multiple linear regression, you only have one Y, one dependent, one response variable. That's it. The other big thing is that regardless of any of this, all of these variables have to be numeric. That's starred and circled and arrowed. All of these variables have to be numeric. You can't use gender, you can't use race, you can't use, leadership style, unless you're somehow coming up with a numeric value for leadership style. So that one's kind of, I guess. But if you're just saying, if I've got authentic leadership and, autocratic leadership and servant leadership, okay, those are groups. That's categorical, right? So all of these have to be numeric. So that is it for this section of the video. And we're going to move on to the JASP demo in the next one.